Hey guys, today I'm here to just play around transactions. So I'm just hoping that whoever is seeing this has a basic idea of what transactions are, so kind of know what asset properties are. So basically, I'll try to play around consistency and isolation over here. So yeah, let's go. So let's just see what data do we have. So just a bunch of people who I may or may not know. So let's just go. Let's just start. So let's begin transaction in this side. So I'm just using two windows to denote two transactions which will work concurrently. So yeah. So okay, let's just take first example. Let's just say, so what I see operations as within transactions are promises which are made, which may or may not hold. So basically, let's say we do update and update. Yeah. So I'm adding 20 as money into the temp, right? So if I do this and if I do select star, I've made a promise that it would be 50. And if I do commit now, this is promise is fulfilled. So if I do this now, I can see that the value is 50. Whereas if I begin the transaction again, and if I do update again, this should increase to 70, and so this is increased to 70. Now if I just do rollback, so now if I try to do this is again gone back. So basically the promise hasn't been fulfilled. So this is how I see the operations within transactions. Promises which are made but which may or may not hold. So these are very, very weak promises, to be honest. Okay, so yeah, let's begin this transaction again. So let's just take the example that the left side, it's an office, and the left side is our manager, and the right side is our bank balance, which I see on Google Pay or something. So let's just say Urvi has got some increment over here. Let's just update it over here. So, whoops. This would be Urvi, and let's say she's got some like nice increment, and this is a promise which the manager has made. So where yeah, so this is 1200. So this is the promise which the manager has made. Over here, if I do select, this is basically the same thing. So this is the side which I am checking right now. You can see that I cannot see this, and this is good because I'm not trusting onto the promise of a manager. So let's say the manager has fulfilled the promise. Yeah, and now if I see this, this has come up in my Google Pay balance. So what I'm saying is I have to trust the things which has been committed, which has been fulfilled, rather than which has just been promised. And which has just been promised, it's not coming. That's good. I mean, well, okay. To explain this, I'll just take another example. Let's just begin the transactions in both of them again. I'll just roll this back. I'll just comment this or whatever. Begin. Okay, we begin transactions in both of them. Now, let's just say I got the increment this time. Right? I got the same kind of increment, and this is the promise which my manager made, and yep, 1200. Now, if I do this, I'm not seeing this. But let's say this promise was being showed over here, and I pre-ordered a book or a football, and let's say there was a function called like buy football. Based on this promise, this has been 1200. So out of that 200, I'll just buy the football. And if the managers just said, there's a hiccup, we can't do this. So uh, what will eventually happen is that I'll only have 1,000. But if I had ordered like 200 of the half that 200 increment, I had bought that football, I would have been pretty broke. So that's one thing. That's dirty read, which they say that if uncommitted things had started to show in transactions, that would have been bad, right? Okay. Now let's move on. Uh, let's just get out of this transaction. Nothing to commit really, but okay. Awesome. Now, now let's just say we come to Sachi and Harshit, our two guys. Okay. Let's say this is the Harshit side. The right side is Harshit side, and the left side is Sachi's side, right? Let's just begin the transaction with both of them. Yeah. So let's just see how much money Harshit has. So Harshit is going to a marketplace, and before going to the marketplace, he's just checking the balance, how much he has in his wallet, so that he's confident enough when he's going outside. So he just checks how much money he has. Oh, he's got a crazy amount of money. He can easily buy some PlayStation or something. So he's got the money. He's got the money. So he's confident. He went outside into the market, and he's gonna try to buy something. Meanwhile, Sachi has got the credit card of Harshit, and he's just trying to buy a headphone or something with that credit card. Okay, let's buy something. Okay. Okay, and let's say this headphone is of 500 amount, and awesome, this is done. Now, well, she has spent it. Now, now she has spent it. That money is gone. That's committed. That's into Amazon's account. That is done. Awesome. Now, over here, Harshit has gone to the marketplace. He's selected a PlayStation. Now he wants to buy. But just before he wants to, he buys it. He just wants to check the balance again, so that he knows like how much money would be left after he's bought the PlayStations for whatever reason. So he just checks his balance again. But the problem is he sees that money is less. For Harshit, he's thinking that he's the only one in the entire world who has the credit card. So he should have seen the same value over here in both the places before and after. So this is called a non-repeatable read problem. So I mean, these two values should have been same. These are not the same because recently committed changes from some other transactions have reflected over here. If this wasn't the case, these two values would have been the same. So that's what a non-repeatable read problem is. Now there's a similar problem like this that's called a phantom read. So it's just it basically says it's a set of rows would be different on the same conditions in two transactions if committed changes start reflecting over here. So let's if there's a query of, let's say, to query how many number of friends, the number of friends who are broke. So I mean, if you have to check that, if one spends some balance in one transaction, before and after of a query would be different. I mean, if I spend like all of my money on something, and if I go broke on one transaction, whereas the others were trying to see how many of their friends are broke, they would see different set of people before and after I've spent it. So that's between the commits, right? So don't worry about that. Just think that phantom read is kind of similar to non-repeatable read, and I'm not going to go over that today. Yeah. Yeah. So the thing is the PostgreSQL. I'm using PostgreSQL, of course. PostgreSQL has different isolation levels. Well, I think MySQL has it as well. So these are different isolation levels at which PostgreSQL can perform things. The default is called the, uh, I think, read committed. So basically, whatever is committed is going to reflect over here. Now, I talked about this non-repeatable read problem. To tackle that, PostgreSQL has a different isolation level. So let's just talk about that. Let's commit this and go out of the transaction. Let's go over here. Okay. So, um, oops. Oops. Yep. So this is it. So if we begin the transaction and say our isolation level is repeatable read, so just an antonym of non-repeatable read. So this would begin the transaction in that state. So we will go through that. Let's just go through that quickly. We begin the transaction in this new isolation level. So again, default was read committed, I think, and this one is repeatable read. So what I'm expecting is that problem of confusion between two states shouldn't be there anymore. Let's just try to repeat that once again. So okay, you see that this is the amount. So over here, let's just subtract the money again. Let's just subtract 500 more. Why not? And commit this change. Over here, in this side, out of the transaction, I can see that this is the amount. This is the actual amount which Harshit has. But in this case over here, even if it's committed, that thing is not reflected over here. So that is something which is good, because now he doesn't have the confusion. I mean, something would hold up eventually. That, I mean, whenever he will try to go for the subtraction of this money, there would something would happen. But at this point, when he's checking the balance, he doesn't see the difference. And basically, he sees that whatever money I had at the beginning of the day and coming to the market, that's the same. So that's good. That holds good. So this is what the problem was, and now we've overcome that. All right. Just to tell you that some constraint violation would happen if constraint violation would happen, or some serialization error would come up if he tries to spend all of his money, which is actually less than the actual amount. So yeah, don't worry about it. The money disappearance. Probably, because we've got some other issues as well. Let's just go out of this transaction and see. Okay. I'll try to create a copycat thing, example or something, whatever. Okay. Let's just begin the transaction. Okay. Now, let's just see how much money everyone has. Okay. Now, me and N, we do have the same amount, but let's just say, okay, not a good example, I should say. So I've made some changes in the data. So I've subtracted 200 from Nan's account. So what I'm gonna try to do is, what me and Nan we're gonna try to do is, we are going to copy each other's values and update it to ours. So I don't want to write unnecessary queries. Let's just go over it step by step. So let's just say I came first. I saw that, hey, Nan's account is 800, so I updated my balance to 800. So now 9 comes up, he sees my balance as 800 and he updates it to 800 as well. So we both have 800 as our balances. Let's just take the reverse case. Um, Nain came in with Nain came in first. He sees my balance is 1000. He updates it to 1000, and then I come up and then I see the balance as 1000. I updated my balance to 1000 as well. So we both have 1000 as value. So basically this means that these has two operations: reading the other's money and updating it to ours. And so these are the two operations for both of us. And the thing is, if this has to be in a certain order to be deterministic. So like I said, if the order was different, we both would end up having different balances, even when we're going to try to do the same exact thing. Just that order is different, the result would be different. So the order is important over here. That's what serializability says. That if in the end the result is not the same, that means it's not serializable. The thing is, that doesn't get caught entirely in this repeatable read that repeatable read isolation level. I'll just quickly show you. Let's just go here. Oops. Repeatable read. This is left side is me, right side is Nan, let's say. Because left side is me. Select from accounts where name equals to Nan. Awesome. Select from accounts where name equals to Vipu. That's what Nan does. We're going to update. We're going to say that, hey, I'm going to update my balance to 800. Awesome. What we're going to do, what Nan is going to do over there is update his balance to 1000. Awesome. Now he would commit, I would commit, and then he would commit, and then we see the balances at the end. So this reflects the same thing, but hey, now we have each other's balances, right? So if you see that this is the third order, that is, the operations are interleaving each other. So that produces a altogether different result altogether, right? So that's the worst. So to deal with all of this, Postgres has this serializable isolation level to just catch this exact thing, these kind of things basically. So let's just go. Repeatable read. Instead of repeatable read, we're going to say that serializable. And over here, we're going to do the same thing. Awesome. Let's just try this once again. I see the Nan's balance. He sees my balance. Oops. He sees my balance. I update according to his. That is, oops, okay. Now it's 1000. Okay. And then he updates. Or, I mean, just before that, let's say I commit this, or whatever. updates it, and that he would update it to 800. Now he has updated it as well. Then I would just commit it like before, and he would try to commit it as before. Whoa, some error. Basically what they're trying to say is that this is not serializable, and the problem which you created, that you won't be able to do that. So this serializable level prevented the basically the issue which I was trying to say, that inconsistencies with the concurrent transactions that would appear. So this isolation level prevents that. So yeah, these were the different kind of isolation levels which Postgres has. I've been trying to wrap my head around these. I had read a lot of theoretical concepts in the college, but I really wanted to do that practically. So here it is. Not a YouTuber, so this is a pretty bad video, I guess. But hey, there you go. So any questions? I would love to discuss them. Love to discuss them. Yeah.